I'll solve this problem, which is very interesting. It has multiple concepts. It should be useful for JEE Advanced and other exams. There is a container which has water, and the refractive index of water is given as 4 upon 3, or so any liquid which has refractive index of 4 upon 3. There is a lens here which is made up of a material which is having refractive index of 3 upon 2. So this lens is placed ahead of this, which has liquid which has mu3 is this, and mu2 is 3 upon 2, and mu1 is 1. This is air. Here there was a glass, there was a mirror with the radius of curvature of 0.4, but we have broken this mirror in two parts, and now this is rearranged like this, and this small gap is filled. This gap is blocked, and now we have placed it in such a way that the axis of the two mirrors which are formed by breaking this mirror are at 1 millimeter from the axis of this lens, and this radius of curvature is 0.4 and this distance is 2. There is a light source here at a distance of 0.4 meters. The frequency of light source is 15 into 10 to the power 14 hertz. There is a screen here inside the water, inside the container. We have to find what will be the width of the fringes which will be formed inside this surface here. So you see there are a number of issues in this problem. First thing to solve such problem is you have to adopt steps. And in such problems where you have three layers, three liquids, three mediums, one, and this is 1, 2, and 3, you can assume that there is same medium on the other side of lens. This is air. Just take a small pocket of air here. So this is glass, say lens, and whatever medium is here. Now first solve where the image will be formed by the lens had there been air on both the sides. I have assumed the pocket of air. So which is very easy. You know the focal length of lens is 0.2, and here it is at 0.4. So you can straight away do 1 upon V minus 1 upon U is equal to 1 upon F. It will be 0.4 only because whenever object is placed at twice the focal length, in case of biconvex lens, the image will be at the same distance, twice focal length and twice focal length. You can check this by using this formula. I'm not doing that. I'm saving the time. These things you should know also so that you can quickly solve the problem. That is how many problems are designed also. So the lens will form the image at 0.4 meters in air. Now what will be the location of this image when there is water here? So now you take another step where you take this water part, this water, and the object for this water will be 0.4 at 0.4 meter, means wherever the lens would have formed the image in same medium which we are keeping on both the sides. Now it is air here. Now we are not putting lens, it is air here. So in this medium it was at 0.4. So now this becomes the object, and we have to find where the image will be formed. So if you know the radius here, if you know the radius of this surface, you can straight away use n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. n2 is 4 upon 3, n1 is 1. So it is 4 upon 3, 1 upon v. I want to find out v, and n1 is 1. U is 0.4 because this was the image formed in air which will be object for this, which is 0.4, and 0.4 here is positive. So it is plus 0.4 is equal to 1 upon 3 into, here you have to be very careful, the radius. what is the value of radius. Now to find radius will be same as the radius of this biconvex lens, and in case of biconvex lens, whatever is the focal length, if it is x, the radius will be x if mu is 3 upon 2. This is the shortcut. Otherwise, you find this by 1 upon f is equal to 3 upon 2 minus 1 when it is air. When there is air on both the sides in case of lens, air, air, and this is 3 upon 2. So 1 upon f is equal to mu 2 upon u1 minus 1, 1 upon r1 minus 1 upon r2. In case of lens, what is r1, r2? You have to be very careful. This is r1 and this is r2. R1 will be r plus r because it is in this direction along the incident ray, and r2 is here. R2 is from here to here. R1 was here to here, so it is positive. R2 is negative, so be careful, it is minus r. So when you put it is 0.5 into 1 upon r plus 1 upon r. So 1 upon f is equal to 1 upon r. So radius is coming same as 0.2 meter for the lens. Don't confuse with the radius, this was for mirror. Now this radius here is 0.2. Now when you are treating this liquid, you see its radius is to be taken as negative because this is the incident ray and radius is being measured in the opposite direction. So here it is. This is very important. Here the mistake happens. Don't do the mistake. Be very careful. Check twice when you are putting the value of the radius here. So you get minus 1 upon 0.6 plus 1 upon 0.4, which is equal to 0.6 minus 0.4 upon 0.24, which is 0.2 upon 0.24, which is 10 upon 12. It is 4 upon 3v. So 3v upon 4 is equal to 12 upon 10. So 3, 4. So v is equal to 1.6 meter. So the image which is formed in the water is at a distance of 1.6 meter from here. So somewhere here this image is actually formed in water. Now this image is formed. Now I just rub it because I have to show you the other important part. Now see, this was the situation where you have these are the two other mirrors. Now image is formed at 1.6 from here, and since it was hole 2, it is 0.4. For this mirror it is at 1 millimeter, and for this mirror also it is at 1 millimeter from the axis. So what is happening? Basically there is a mirror and you have the object at a distance. So this is the height of the object. So the height of the object for both the mirrors is equal to, here the object is placed like this and here the object is placed like this. Same object, but for two mirrors it is being, you have to see this from the, its height is to be seen from the axis of the mirror. Now what is the radius of curvature of the mirror is 0.4, so focal length of the mirror is 0.2. In case of mirror, the radius of curvature will be twice the focal length. So focal length of the mirror is 0.2. So what is 1 upon v plus 1 upon u is equal to 1 upon f. F here is in this direction. So f has to be taken as negative. So 1 upon v is equal plus, what is the distance u is 1 upon, it is in negative direction opposite, so minus 0.4 is equal to 1 upon minus 0.2. So 1 upon v is equal to 1 upon point. Straight away also you can do, it will come minus 1 upon 0.2 or 2 upon 0.4. So v is equal to minus 1 upon 0.4 So V is equal to minus 0.4 means it is at the same place. Negative means at the same against the incident ray, but it will be inverted. So image will be here, and for this it will be here. In case, like we know, in case of lens, if the object is at twice the focal length, that image is also at twice the focal length. Here also, when the object was at twice the focal length, the image will also be at twice the focal length, but inverted image in case of mirror. Real image is being formed, which will be inverted. So image, you again try to see, I am just repeating it. Here was this was the spot where image is formed, but from the axis of both the mirrors, it is like an object with this much of height. This is 1 millimeter, and its image is also formed under it. Its image is formed here. So this will be 1 millimeter, this will be 1 millimeter, because magnification is 1. So this height, this height. So effectively you are having two images, which are two objects for creating interference, which are at 4 millimeter distance. So this was the most crucial part. Once you find this, the distance between the two sources, so now simply apply the formula. Beta is equal to d lambda upon d, means the width of the interference pattern. What is d here? D here is here are the images formed. This distance, small d, is 4 millimeter, and this is capital D. From the screen it was 1.6. So D is 1.6, small d is 4 millimeter, 1.6 meter, and lambda is how much? In this case, be very careful that lambda will be equal to, or let me write lambda dash, because when you do not have air, if there is any other medium, use lambda dash, and lambda dash will be lambda upon 4 upon 3, means the refractive index of water. And what is the relationship between speed is equal to lambda mu? Speed of light is equal to lambda mu. Mu is given to us, c we know is 3 into 10 to power 8, so lambda is 3 into 10 to power 8 upon 15 into 10 to power 14. Put the value of lambda there, you will get lambda dash, and put the value of d, you will get the width of the fringes. So you see, in one problem there were number of issues, so that is why I thought I will take up this problem.